This Webex service includes a feature that allows audio and any documents and other materials exchanged or viewed during the session to be recorded. By joining the session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This Webex service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, what we're going to talk about today is the chapter on methods, Chapter 6. It introduces an opening problem. The opening problem is to find the sum of the integers from 1 to 10, from 20 to 30, and from 35 to 45, respectively. Let me just see who just joined. We have, oh, nobody. Okay. All right, so you should recognize that this looks to be like the same code. The only difference is we have a starting point and an ending point that are different in each of the three different cases. 1 to 10, 20 to 30, and 35 to 45. But everything else is going to be the same. It's going to be the summation of all those integers within that range. Up until now, this has been the solution, which would be to write 3 separate routines. The first one to handle the range from 1 to 10 using a for loop and accumulating into an accumulator called sum, and then printing it out. And then repeating the code, initializing the sum counter or the sum accumulator to be equal to 0, and then accumulating the sum from 20 to 30 and print that out. And then finally for the third occurrence as well. That's not as efficient as the way we would want it. A better solution would be to go ahead and take these 3 routines and write one routine, call it a method, and make sure it has the following structure. Inside your main method, you would do 3 straight system.out.println statements and state the sum from 1 to 10 is, and then at this point, you invoke the sum method, passing it 2 parameters. The first is the starting point, and the second is the ending point. When you place values in those parameters, they become arguments to this method. So the first argument is the integer 1, and the second argument is the integer 10. Up here is the actual method description. We have public static int sum, int 1, and int 2. What that means, these first 2 words, public static, are modifiers. We'll talk more about that later in the semester. The next int is the return type that's going to come from this method. The method name is sum, and inside the parentheses are parameters. They're separated by commas, so we have 2 parameters. The first one is of the type int, and it will be referred to as I1 within this method. The second one is of the type int, and it will be referred to as I2. The method begins here. The method block begins at the open curly brace, closes down at the closing curly brace, and here is what we're going to do regarding the sum method. The first thing we're going to do is initialize the sum accumulator to be 0, and we just do a quick for loop where we start at I1, which in this case gets passed from this statement and this method call, and I1 will be 1 and I2 will be 10. Now what we'll do is we will accumulate into sum plus 1, then sum plus 2, sum plus 3, sum plus 4, and we'll eventually get the sum of all the integers from 1 to 10. It will then return the variable sum up here, and whatever that accumulation is will then get replaced in where this orange box is, and it will print out the sum from 1 to 10 and whatever that value is. The next invocation of the method is the second statement printout statement, and it will pass two different parameters. It will pass 20 and 30. Those get put into I1 and I2, and we do the same process. And then finally, the third step is to invoke the sum method, passing it two different arguments, 35 and 45, and that will get the sum of 35 to 45. So this is a much more efficient way of designing your solution as opposed to the three separate blocks of code. This is a much smaller solution, and it is a little bit more understandable and clearer, where you have this as your main method and you call this sum method. Okay, a method is a collection of statements that are grouped together to perform a particular action. We have here the max method. Let's make it a little larger. All right, so the max method is going to receive two integers. It will be referred to as num1 and num2 inside this method. And here is the method body. And over here in, let's say, for instance, the main method, you will invoke the max method and pass it two arguments, x and y. X, I'm not too sure what x is. Let's say x is 1 and y is 2. Now the values 1 and 2 get passed into the max method, and they will be referred to in this method as num1 and num2. And the logic is pretty simple, is if num1 is greater than num2, then return num1, else we'll return num2. So it's returning the larger of the two integers that gets passed. This result gets passed back and replaces this method call. So in this case, it would be 2, and then the value 2 gets assigned into the integer variable z. Here's some terminology for you to understand. As I said earlier, the public static are two modifiers, which we will talk about later. The next is the return type value. In this case, it would be an integer that was getting returned from this method. The method name is max, and here is the formal parameter list. We have two parameters. They're separated by the comma. The first parameter is num1. It's of the type int, and the second parameter is num2. It's also of the type int. This inside the box is what's known as the method signature, and the method header is the entire piece all the way to the curly brace. And then inside the curly braces, the opening and the closing is the method body. I'm going to skip over that because I just went through it. Let's go take a look at an example. We'll use the max method as an example. All right, we're going to go ahead and run this, and it says the maximum between 5 and 2 is 5. So we've got a main method, and we are initializing I to be 5 and j to be 2. We'll invoke the max method, passing it I and j, so it will get the values I being 5 and j being 2. And down here is the max method. It's going to return an integer, and I and I and j, which are 5 and 2, now become num1 and num2. We declare a variable for our result, and if num1, which is 5, is greater than num2, we're going to take num1, which is 5, and return it back into result. Otherwise, num2, which is a 2, would get returned, but that's not the case. 5 is larger than 2. So result gets a 2, and it gets returned, and we now go back from whence we came, and where do we come from? Right here. And the 5, the larger of the 2, gets replaced or replaces this section highlighted here. the integer 5 then gets assigned into this integer variable k, and now k will contain a 5. And this printout statement says the maximum between I, which is 5, and j, which is 2, is going to be the value k, which we assigned to be 5. So that's how a method is developed, and it's how it gets called and how the return value gets passed back into another method. In this case, it's the main method. And inside the main method, we're calling the max method. Okay, I'm going to quickly go through this because I just stepped through this. This is the trace of the method max invocation. Now it says here a return statement is required for a value returning method. The method shown below in A is logically correct, but it has a compilation error because the Java compiler thinks it's possible that this method does not return any value. So over in A we have an error, and over in B it's corrected. Essentially, this method, which is the sign method, is going to return an integer, and it's going to receive an integer. And in here we're going to determine what the sign is. Well, n, if n is greater than 0, we're going to return a positive 1. Else, if n is equivalent to 0, we're going to return a 0. Now this else if n is less than 0, returning a -1 will generate a compiling error. You really do not need this else if section here highlighted in yellow. All you really need to do is remove the highlighted yellow and just say else return -1, which is what's over here. Because the compiler thinks that there could be another condition where this if clause yields a false, and it cannot. It's always going to be, if it's not positive and if it's not neutral, it's got to be negative. So you need to remove this highlighted if. Now, one of the benefits of methods is for reuse. The max method can be invoked from any class besides testmax. If you create a new class called test, you can invoke the max method using classname.methodName, for instance, testmax.max. So many methods are developed, and then they can be stored in a class called, let's say, testmax, and then to access that method, you need to reference the class name first, followed by a dot, and then followed by the method name. So this max method can be stored in a class called testmax and then invoked using this syntax. Okay, stacks. Here's an example of where things actually get stored. When you receive control, when your main method gets control from the Java virtual machine, an activation record is created, and it gets placed into what's known in storage in an area called the stack. If we go through our example where we invoke the max method from the main method, well, the main method created 3 variables, and they get stacked on top of one another, as do the activation records. So the first variable that got declared and initialized was I, and we have it represented here. Next, the variable j was declared and initialized to 2. Third, the variable k was declared but not initialized. We didn't know what that was. So in this activation record for the main method, we have these 3 variables. Then, as the code gets processed, it calls another method, the max method. When that happens, the max method creates another activation record stacked on top of the main method activation record. And here is where we pass the values 5 and 2 over to num1 and num2. The max method does its thing and passes back the 5 right here back over into K, and then this activation record for the max method goes away. It gets removed from the stack. And now the only remaining activation record is the main method activation record. And then once that main method relinquishes control back to the Java virtual machine, it will go ahead and get removed from the stack, and now the stack is empty. So that's the processing with methods. They get activation records, and those activation records get stacked on top of one another in the area in storage known as the stack. This is a trace on the call stack. I'm not going to spend too much time with it. I'm going to skip over it quickly because I just stepped you through that. But the next topic is the void method example. This type of method does not return a value. The method performs some actions. A void method must be a statement. For example, print grade 78.5. So the print grade method is going to have a void return type, and it must be in a standalone statement. Let's look at test void method. Okay, inside our main method, we're doing a printout and saying the grade is, and now it's a standalone statement. This is a void method. It has no return type. We're going to call print grade. We're passing it what looks to be a double. Let's go down to print grade, our method. Sure enough, we're receiving a double, and it's going to return nothing. So we're getting 78.5 into the variable called score. And now we're looking to see if 78.5 is greater than 90. That's false. We'll go to the next else. If 78.5 is greater than 80, that's false. Else if 78.5 is greater than 70, that's true. And we will print out the character C. We've already printed out the grade is, and then the only thing that's remaining is the actual grade for 78.5, and that will go ahead and print out the character C. And then we come to the end of here, and we return back to the original calling, returning nothing back, and there is no further instructions beyond the print grade call. So the program ends, the main method returns control. All right, so that's an example of a void method. Let's look at test return grade method. This is a little bit different. So the same solution with a different approach. All right, we have our same two printout statements, but in this case, we're going to go ahead and concatenate a new method call called getGrade, and we're passing it 78.5. Now, getGrade is a little bit different. GetGrade does have a return type. It's of the type char. It's going to be receiving a double. It will be referenced as score inside this method called getGrade, and 78.5 goes into score, and if 78.5 is greater than 90, that's false. Greater than 80, that's false. 78.5 is greater than 70, so it's going to return a C, and the C gets, this gets replaced with the C, so the printout statement is the grade is C. It will then do the next statement and pass a 59.5 to the getGrade method. Let's run that so we can see that the results are going to be the grade is C, and the next statement up here is going to generate the grade as F. And the 59.5 goes through the same logic. So now 59.5 is score. It comes all the way down through this if, else if, till it finally realizes that the only thing left after 60 is to return an F. And so F goes into here, and it will replace the get grade call with an F. And then the program ends. So that's a little different design of the same type of problem. This one is invoking a method that does have a return type. The other one was a void return type. Keep in mind that the void return type needs to be on a standalone line. It's a separate statement. You cannot assign anything because you're not getting any return type. So you couldn't go ahead and take the return type and assign it into another variable like we did earlier. I'm going to skip over this. I already did this. I don't know why we're going through this again. Next topic is passing parameters. We have a new print method called endPrintLine. And in this case, it's receiving two parameters. The first is message. It's of the type string. And the second is n, which is of the type int. Starts here, it ends there, and we've got a very quick for loop. It only has one statement that loops, and we're starting at I, and we're going to continue for as long as we go to n, whatever the n is that gets passed, and it will go ahead and print out the message, which is the string that got passed in the parameter list. Suppose you invoke the method using the following method call. What is the output? We have endPrintLine, welcome to Java, comma 5. This will print out welcome to Java 5 times. The next method call, which is endPrintLine, computer science, comma 15, will print out computer science 15 times. This last question, can you invoke the method using endPrintLine 15, comma computer science? The answer is no. It has to have the arguments must be of the same type in order, number, and compatible type as defined in the method signature. Compatible type means that you can pass an argument to a parameter without explicit casting, such as passing an int value argument to a double value parameter. So you can go ahead and pass an int to a double because that would be implicit casting, and there is no precision loss. Passing an int to a double can clearly fit in a double. Passing an int, let's say 1 over to a double would be 1.0. So you've lost no precision. You cannot go the other way. You cannot go ahead and pass a double like 1.1 over to an int or 1.0 because now you're losing precision. And they must be in the same order and of the same compatible type. When you're passing parameters, there are two ways in which you can pass parameters. One is pass by value, and another one is pass by reference. In this chapter, we're going to talk about passing parameters by value. If the argument is a variable rather than a literal value, the value of the variable or a copy of the value is passed to the parameter. The original variable's value is not affected regardless of the changes made to the parameter inside the method. This program demonstrates passing values to methods. Let's look at test pass by value. Okay, we have two ints, num1 and num2, both being assigned 1 and 2, respectively. Now we do a print. I'm going to print this so we have it down below. Okay, so before invoking the swap method, num1 is whatever the value of num1, which would be 1, and num2 is num2, which would be 2. And sure enough, down here, it gets printed out. Num1 is 1 and num2 is 2. That's before invoking the swap method. Now we're going to invoke the swap method, and we're passing it num1, which is 1, and num2, which is 2. Let's go down to our swap method. And here's our swap method. We're going to return nothing, so this is a void method. And we are swapping num1, the value of num1, which is 1, and the value of num2, which is 2. And they will be those two values, so they're going to take a copy of those values, num1 and a copy of num1 and copy of num2. And so we'll put the value 1 in n1 and the value 2 in n2. Next, it tabs over and says inside the swap method, and then a couple of tabs. Before swapping, n1 is going to be 1 and n2 is going to be 2. And that's right here. N1 is 1 and N2 is 2. Now we swap, and we all know that technique. In order to swap N1 and N2, we need to declare a temporary work variable called temp of the type int, and we'll go ahead and move N1, which is the 1, into temp, and then we'll take N2, which is a 2, and move it into N1. So now N1 has a 2, and then temp, which currently has a 1 value, is going to get placed into N2. So we've essentially swapped the two values. Now, at this point, N1 has a 2 in it, and N2 has a 1 in it. We print out, after swapping, N1 is N1, and N2 is N2. So after swapping, N1 contains a 2, and N2 contains a 1. We return back. We're done with this swap method. It started here and ends right here. We're now going to go back from whence we came, and it was at this point we do the next sequential instruction, and we're doing a print line on, after invoking the swap method, num1 is num1 and num2 is num2. They still remain 1 and 2. Num1 is 1 and num2 is 2. So regardless of what's going on inside the swap method, these values remain unchanged because they are passed by value, not by reference. If you wanted to pass something by reference, you're going to be passing the address of that particular item, and then inside the method, it's going to be referencing the address, which is the original place in storage, and those storage areas will be changed from that method call. But that'll be for another chapter, another topic. So for primitive types, num1 and num2 of the type int, these get passed down here by value. And here is how that would work using the activation records. I'm not going to go through that. Methods can be used, this is for modularizing code or coming up with smaller packets of code. Methods can be used to reduce redundant coding and enable code reuse. Redundant coding would be the very first example where we had the redundancy of the three ranges that we needed to print, 1 through 10, 20 to 10 to 20, and 25 to 35. Methods can also be used to modularize code and improve the quality of the program. Once you create a method, it can then be used by yourself over and over again. And as well, many of the people that you work with, your other programmers, can go ahead and use these methods once they have been fully tested and been installed into a production library. Then they can go ahead and be invoked from your program. So you don't have to rewrite these, what oftentimes can be a very complicated method. Let's look at the greatest common divisor method. Okay, we have, let's bring this down a bit. Make this a little larger. All right, we're getting scanner input, and we're going to ask the end user for a first integer. We'll put that in N1, and we're going to ask for a second integer. We're going to put that in N2. And we know what the greatest common divisor is. If I was to give you an example of, let's say, the greatest common divisor of 6 and 9, well, we can do the mental math and say that that greatest common divisor, the GCD, is going to be 3. So let's use these two as examples. N1 is going to have a 6, and N2 is going to have a 9. The greatest common divisor for N1, or 6, and N2, or 9, is we're doing a method call. The GCD method is being invoked, and we're passing it two parameters, N1 and N2, and we're going to pass, what are they? They're ints. So 6 is going to be N1, and 9 is going to be N2. They do not have to be the same names. As a matter of fact, I strongly suggest you come up with different names so you don't get confused between the N1 inside the main method and the N1 inside the GCD method. So we now have the GCD method down here using the same variable names, N1 and N2, both of the type int. It will return back an int, presumably going to be the greatest common divisor. And here's our little tricky routine to figure out what is the greatest common divisor. We'll initialize the GCD to be 1 because 1 goes into everything. And we'll start K, which will eventually be a work variable that will determine the greatest common divisor. We'll start that with K. We'll start that with 1, excuse me. Now we've got a while loop that goes from here to there. And we're going to ask the question, if N1, which is 6, modulus K, K is 1, if that's equivalent to 0, and it will be because anything divided by 1 is going to have a remainder of 0, ANDed with N2, which is 9, modulus 1, equivalent to 0. So that also will be true because 9 modulus K will yield a 0 remainder. We have a true ANDed with another true, and that overall result will be true. So we do the next instruction inside here, and there is no curly braces, so the if block is only one statement, and we're going to assign K into the GCD. It's rather redundant because we initialize K to be 1, and now we're assigning 1 into GCD. Now we're going to increment K. So now K is 2. And we'll do K, while K2 is less than N1, 6, and K, which is 2, is less than or equal to N2, which is 9. So that is true. And now we're going to ask if N1, which is 6 modulus 2, is equivalent to 0, and N2, which is 9 modulus 2, is equivalent to 0. The first part of this is true, but we're ANDing a false. 9 modulus K, or 9 modulus 2, is not equivalent to 0. We have a remainder of 1. So therefore, we don't do the loop, the if body, and we're going to skip over that condition when it's true, and we're just going to increment K to 3. While K is less than 6, that's true, and K is less than or equal to 9, That's true. Now we're going to do if 6 modulus 3 is equivalent to 0. That's true. ANDed with 9 modulus 3 is equivalent to 0. Those are both true. So we're going to go ahead and take k, which is 3, and assign that into GCD. This will continue looping up until the point where we get to 7, which is 1 more than the smaller of the two integers. And we're going to say while 7 is less than or equal to n1, that's false. A false ANDed with this will be true. 7 is less than or equal to 9, but a false ANDed with a true is going to be an overall false. And we are going to get out of the while loop, and we're going to return the GCD. In our example, it will be 3. 3 gets returned back here, and this print statement will print out the greatest common divisor for 6 and 9 is going to be 3. So this is a method called the GCD. The point on this is that we have a main method, starts here, ends down here, and here is like your mainline logic. You're doing some, you're asking for 2 integers, and then we're calling a greatest common divisor method to print out whatever the result is. That mainline logic is rather straightforward. If I was to include this, I'll call it convoluted logic, in the mainline processing here, it would get very disguised and obscured as to what the mainline logic is doing. So it's a good idea to go ahead and create a method that many people can use. There may be a need for GCDs in other programs. So you might want to create a method called GCD, get it out of your mainline logic, and declare it and develop it down here inside this class called greatest common divisor method. Oops, sorry, let me get to this here. Okay, so I'm not going to go through the prime number method, but it's the same type of thing. To determine a prime number is somewhat complicated, and it's a rather creative solution. And I'll leave it up to you to go take a look at the prime number method. It's posted out there in Blackboard in the program section. And you can see that there is a separate method called the prime number method that the mainline logic calls, okay, in the main method. And you can step through to see exactly how this prime number method actually does ascertain whether or not an integer is a prime number or not. And it just gets passed back as a Boolean, I believe, true or false. So in this case, you know, it will determine if a prime number is a prime number. It's got to either be divisible by itself or 1, and that's it. And the prime number method determines that. Okay, write a method that converts a hexadecimal number into a decimal number. We've done every combination going, I think, up until now, except hexadecimal to decimal. So let's look at this code, hex to decimal. I will run this, and you'll see that if I enter a hex number, and I'll enter 1F, and the program comes back and says the decimal value for hex number 1F is 31. And I can mentally check that because I know that a 1F in hexadecimal is 1 group of 16 and F groups of 1. So I can go ahead and add those two. F is a value of 15. So I have 1 group of 16 and I have 15 groups of 1. 16 plus 15 is 31, so the program checks for a simple example. Let's see how it's constructed. We're getting scanner input, and I am going to enter my 1F into a string variable called hex. So my 1F now goes into the string variable hex. The next is a print statement. The decimal value for hex number 1F is, and now I am invoking the hexadecimal method on another method call. This particular method call is the toUpperCase method. Over in the string class, there is a toUpperCase instance method inside the string class that we now can invoke. We've created on an object. The object is hex, so I can now use the toUpperCase instance method in the string class on the hex object, and that will take my 1 and my lowercase f and flip it to uppercase f. So this method call will flip it to 1 uppercase f, and then this method call, hexadecimal, will work upon 1 uppercase f. Hexadecimal is right here. It's expecting a string. It's getting 1 uppercase f, and it's going to return an integer value, which is just what we want. We want the decimal value of 1f. Here's what goes on inside this, I'll call it complicated, hexadecimal method. We're initializing decimal value to be 0, and we're doing a for loop, and this for loop will go ahead and take hex character at 0, which is the 1, and assign it into hex char. It's of the type char. And now we're doing a decimal value times 16. Decimal value is 0, so it's going to be 0 plus hex char to decimal on hex char. So what is hex char? Hex char is 1, and that gets passed to hex char to decimal. That's this method down here. It's receiving the 1 character, and it asks the question, if CH, which is the character 1, is greater than A, and the character 1 is less than the character F, in other words, is the character 1 within the range of A and F? That is not the case, so that's false. We're not doing this return. We're going to go to this else, and we're going to return CH, which is the character 1 minus the character 0. And that's going to be the value of 1. So the value 1 is going to get returned from this evaluation, which is of the type int, and this now gets placed into here, and this whole thing is a 1, so 0 times 16, which is 0, plus 1, now gets assigned into decimal value. Decimal value contains a 1 in it, and we're not done. We're still going to go ahead and now bump I to be equal to 1. And we're going to go for as long as we have hit the length of the hex string that I entered. So it's only going to go one more time. This particular time, we're taking the character at 1, which is my F, and assigning that into the hex char. And then we're going to go ahead and do decimal value, which contains a 1 times 16. So that's going to be an overall 16, plus hex char to decimal on hex char, which is now uppercase F. This now gets put into the CH variable of type char, and it asks the question if CH, which is a character F, is between A and F, and in fact it is. We're going to return 10 plus the character F minus the character A. The character F minus the character A is an overall 5. It's a value 5. To go from A to F is to increment up 5 times. So we have a 5 plus 10 is going to be an overall 15 getting returned. 15 is of the type int, and it will come back to here, and I now have 15 replacing this expression. I have decimal value 1 times 16. That'll be a 16 plus 15. That's an overall 31 getting assigned into the decimal value variable right here. And we are done with our for loop. And the for loop will then return the value decimal value here. And we now come back up to the top, and we will replace this long expression with 31. And that is how this rather complicated hexadecimal method gets invoked. And it actually invokes 2 methods. It invokes the hexadecimal, and it also invokes the hexachar to decimal value as well. Next topic is overloading methods. Overloading the max method. Here is the max method, and it receives 2 parameters. The first one is num1, it's of the type double, and the second parameter is num2, also of the type double. And we know how this works. So let's look at test method overloading. In this particular case, we are printing out the maximum between 3 and 4 is, now we'll pass the 3 and 4, these are both integers, to the max method. If we look down here, we have 3 different max methods. This max method is going to work upon parameters that are strictly integers. This max method is going to work on strictly 2 doubles. And then the final one is going to work upon 3 parameters, all of the type double. So it has the same method name, but it has different return types and different parameter lists. Let's step through this code. The first one is going to be a method call using 2 integers, 3 and 4. Okay, that will use this first max method because it's going to try and match. And by the way, the method bodies can be different. But in this particular case, these 3 method bodies, the first 2 are identical. The third one is a little bit different. We'll get to that in a second. So this method call on 3 and 4, num1 is 3, num2 is 4. It will return the max num4. Num2 is going to be 4, and that will get returned back. And 4 will get in place of that. And here, whoops, the maximum between 3 and 4 is 4. The next method call, we're passing max 3.0 and 5.4. Those are 2 doubles. Well, it's not going to match up with this method signature that has 2 ints. It does match up with 2 doubles. So this is the method call. This is the method, the max method that will be used. And this will return the maximum of 3.0 and 5.4. And we're going to get this printed out using that method call. The next one is going to invoke the max method, and it's going to have 3 arguments. 3.0, 5.4, and 10.14. It will look to determine which max method matches, and we have here a double, and a double, all three getting passed. So num1, num2, and num3 will have 3.0, 5.4, and 10.14 respectively. And look what this does. This does a quick return on max, num1, num2, comma, num3. We'll work from the inside out. So this is the first method call, and it's going to return the maximum between num1 and num2. We're receiving two doubles for num1 and num2, so it will therefore use this method for the first invocation, and in this case it's going to return 5.4. Right here will get replaced with 5.4. Now we have max on 5.4, comma, num3. Num3 is 1014. That is also a call on two doubles, so it will return 10.14. So now we have 10.14 getting returned to here, and this will now get replaced with 10.14. So this is a rather tricky method overloading, where you're actually using another method with inside this method, both of the same name. And then last but not least is max call that we're calling 3, 5, and 10. Now it said it's of the compatible type, so we're doing integers here. So it's 3, 5, and 10. We can go ahead and invoke this max method because it requires 3 parameters, and although they are not ints, they are doubles. This is what's known as type widening, which is permitted, and we can now go ahead and follow the same process that I just stepped you through for the 3, 5, and 10 as if they were doubles. This would get converted over 3.0, 5.0, and 10.0, which is why the result comes out as a double 10.0. All right, so that's method overloading. Sometimes there may be 2 or more possible matches for an invocation of a method, but the compiler can't determine the most specific match. This is referred to as ambiguous invocation, and this becomes a compile error. I keep losing my mouse for some reason. I'm not too sure why, but all right, let's take a look at ambiguous overloading. I didn't do ambiguous overloading. I'll show you what this is in the PowerPoint. For instance, here we are passing max 1, comma 2. These are both ints. Well, it'll look to see what's the best match without explicit casting. Well, we have int num1, that corresponds with that, and double num2, well, that can be widened to be that, so this could be used. But by the same token, this max method down here could also be used, because this int can be widened to a double implicitly, as well as this 1 can be widened to a double, and this 2 can be maintained as an int. So it's confusing. It's confusing to the compiler, and this is what's known as an ambiguous invocation in attempting to overload. And you will get a compile error. You're going to need to fix that. Okay, this is a little bit of a review, I think, but we're going to go through it, and we'll talk about the scope of local variables. A local variable is a variable defined inside a method. Your main method has local variables in it. The scope of the local variable is the part of the program where the variable can be referenced. It's visible. You can actually take a look and see what's inside that area in storage. The scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. A local variable must be declared before it can be used. You can declare a local variable with the same name multiple times in different non-nesting blocks in a method, but you cannot declare a local variable twice in nested blocks. Let's step through an example. What we have here is a public static void method 1. So inside this method, I am declaring an int variable called I, highlighted in this turquoise color. And the scope of this variable I starts from its declaration, and it will continue down to the bottom of this for loop inside this block. You cannot reference I outside this block, such as after this for loop or before the for loop. Here we have another int variable called J, and its declaration starts here, so its scope only goes from its point of declaration down to the bottom of the for loop. And you cannot reference I or J outside down in here, let's say. It is fine to declare I in two non-nesting blocks. Here we have X and Y inside the void method 1 block, and now we have an int I declared inside this for loop, and we have another for loop where we can go ahead and declare another I of type int. This is fine because these are not nested for loops. And we can also reference X inside this, because this is a nested block inside the method 1 block. We can reference X here. We do not need to declare it. We cannot declare it again. And likewise Y. It is wrong to declare I in two nesting blocks. Here we have I getting declared inside the method 2 block, and then we have another nested block where we are declaring I inside this for loop. And this is wrong. This is a nested for block inside the method 2 block, and this is not going to be permitted. This is a duplication of what I just said. And the next topic is method abstraction. You can think of a method body as a black box that contains the detailed implementation for the method. As I'm sure you've kind of concluded by now, the assignments are getting a little bit more and more challenging, and they get a little bit more complex. As you start to figure out solutioning and start to solution some of these complex problems, it's probably a wise idea to create a method so that it can be reused, and the next person doesn't have to go through the same toil and rigors of creating a routine. They can just use your method. So methods lend themselves to be complex, and you test them every which way, and then you go ahead and put them in a class that can be invoked for other programs to use. So this method abstraction is a concept that essentially means programmers don't really need to know how the actual method works inside the method body. Their only real concern is what is the method header? What is the name of the method? And what are the arguments for input? And what's going to be returned back from the method call. Inside the method body, it could be very complex, convoluted code that nobody really is concerned about, other than the fact you want to be concerned that it works and it's been thoroughly tested. So it can be a black box, or it's known as method abstraction. Very much like abstract art is a good example. If you ever took a look at a painting by an artist that does abstract art, it's very hard and it's somewhat hidden as to what the real meaning of that piece of artwork is. Well, that's known as abstract art. The same concept can be applied to method abstraction, where it's rather hidden as to how the actual method accomplishes its task. All that's needed to be known is the header and the return value and what you need to input. The benefits of methods, well, write a method once and reuse it anywhere from anyone that has access to that library. It also provides information hiding. You can hide the implementation from the user. If you developed a rather complex method and you don't want other people to steal it from you, whether it's customers or other competitors, you can go ahead and hide the implementation and make it such that it cannot be stolen. And again, as I say, it reduces the complexity of your mainline logic, and therefore your overall complexity of your overall program. All right, here's a case in generating random characters. Random characters is a unique Unicode between 0 and hexadecimal 4Fs. A char data type is 2 bytes, so in 2 bytes you can handle up to 65K different types of characters, whether they are wingdings and smiley faces, or alpha, beta, pi, or the normal keys on a keyboard. We have way more than what we need to, than what we use, but there is a total of 65,535 different decimal values for character data. To generate a random character is to generate a random integer between 0 and 65K using the following formula. And I'll just skip right down to it here. You can call the math random method inside the math class, pass it this expression, and it will generate a random integer that will represent any character between, the values up to 65K. Now let us consider how to generate a random lowercase character. The Unicode for lowercase characters are consecutive integers starting with a Unicode value for lowercase a, and the Unicode value for lowercase a is a 97. Lowercase b would not be 98. Lowercase c is value 99, etc., all the way up to z. You can go ahead and express this in Java code as the character a surrounded by single quotes, and then cast it to an integer, and that will get cast to a 97, a value of 97. So a random integer between a and z casted to integers is, and then here's the expression for that, where we're using characters to define our limits or our zone, and then casting things to integers. As discussed in Chapter 2, all numeric operators can be applied to the char operands. The char operand is cast into a number if the other operand is a number or a character. So the preceding expression on the previous slide can be simplified as follows. You can get rid of all that casting because it's done implicitly, and you can say lowercase a plus the math.random method, and then z minus a plus 1 will generate a lowercase random character. So a random lowercase letter is now needs to be casted to a char, and now it becomes a letter, an actual character. So you take this expression here and put a casting of a char in front of it, and it will go ahead and create a lowercase character that is randomized. In summary, here is the formula. Between any two characters, where CH1 and CH2, CH1 being less than CH2, so you could do CH is A and CH2 is D, and you'll get random characters between A and D. Let's look at the test random character class. If we look at this here, we're going to see that inside this test random character .java file, there are two classes. There's the test random character class that starts there and ends there. It's got a main method. And then there is another class called random character. And inside this random character class, there are many different methods. Get random character, return a character, it gets passed characters. Get random lowercase character will return back a lowercase a to z. Get random uppercase letter will return the uppercase random uppercase a through z. Another method called get random digit character returns a random digit between 0 and 9. And then this get random character will go ahead and just return any random character between Unicode 0s all the way to Unicode Fs. So there are your many methods within inside this class called random character. A question that was brought up in another section of one of my classes said, why isn't this public? After all, every class up until now, we've had a modifier of public class test random character. And the answer is if you're going to put two classes within inside a .java file, Java only allows one of those classes to be public. Now, you can put multiple classes inside a file, but only one can be public. So this is just class, which means that it has no modifier, so that would mean that its modifier is the default package, which means it's addressable within this package, test random character, all in lowercase. Let's run this, and what this does is it will generate a whole bunch of random characters. And the number is going to be a total of 175 random characters, and we're going to print 25 random characters per line. Those are my constants declared right up top. And here are the 7 lines of 25 random characters, totaling 175. We have a for loop. And this for loop starts at 0, and it's going to go for as long as it loops up until number of chars. Number of chars is 175, so it'll go for 175 loops. And we are going to call the get random lowercase letter method inside the random character class. That is visible because it's in the default package, and that means that it can be found right here inside this file. And sure enough, here is the random character class, and we have get random lowercase letter method inside there. It's right here. And we can go ahead and it will return. It's going to do some calling to other different methods. Here's get random character, and that can be found all here. But my point is that all of this gets removed. This is almost like method abstraction. We don't necessarily need to follow all of these returns for all these different char types. But what this is doing is it will handle all the different types of randomizing of characters, whether it's lowercase or uppercase or digits or just a general character. These methods will go ahead and accomplish all of that. And all you really need to be concerned about is the fact that this method call inside this class called random character will go ahead and generate lowercase characters, and then the rest is rather straightforward. We're starting I at 0, so we're going to add 1 to it. So if 1 modulus characters per line equals 0, that's not the case. 1 modulus 25 is not equivalent to 0. But when we get 24, the 25th loop, well, now 24 plus 1 is 25, modulus 25 is equivalent to 0. Then we're going to start a new line. This has the print line method. If it's not evenly divisible by 25, we're just going to go ahead and do the system.out.print, which will append the random character to the end of the string. Whoops, stepwise refinement right here. The concept of method abstraction can be applied to the process of developing programs. When writing a very large program or a system of programs, you can use the divide and conquer strategy, also known as stepwise refinement, to decompose it into subproblems. The subproblems then can be further decomposed into smaller, more manageable problems. The book gives the example of printing a calendar. Let us use the print calendar example to demonstrate stepwise refinement. This is the actual problem. Let's say the customer wants a calendar printed, the calendar month, and you need to provide the year and the month. In this example, we are providing 2009 for the year, and the month is going to be April. And your program gets 2009 and 4, and then prints out this nice header, and it also determines which is the start day. It was a Wednesday, and the end day, we know that April has 30 days, and every April has 30 days, but not all months have the same number of days. So as you can see, this can be quite a complex solution. Using stepwise refinement, you can break this problem down into smaller and smaller and smaller parts. Here's the design diagram where we want to use a top-down approach. We need to print the calendar. So we're going to develop our mainline logic. First thing we need to do is read input, and then there's another process block over here to print the month. To print the month is going to require printing the month title and then printing the month body. Printing the month title, well, you're going to need to go ahead and transform the 4 over to the string April. So it'll be a process, a stepwise refinement so that we are able to get the month name of April. The month body, you're going to need to know what the start day is. In the case of April 2009, it started on a Wednesday. So that is another piece that's going to have to be written. That program, that method will have to be written. And then another method would be get number of days in the month. April has 30, December has 31. The tricky one is February, because February has 28 normally, but on leap years it has 29. So you're going to need to get the total number of days and put that into the total number of days per month and determine whether or not it's leap year. So as you can see, this design gets a little bit complex, and the way in which you can go ahead and implement this development is to use a top-down approach and come up with what's known as a skeleton for the print calendar. Let's look at the skeleton. Okay, here is the skeleton, and inside here is your main method, and you're asking for the year, and you're asking for the month. Our example, we're using 2009 and 4 for April. And here is a method call on print month, passing it year and month. Here is the method print month. It's receiving year and month. It is a void method. It's returning nothing, so it's going to continue its processing. And each one of these methods is basically what's known as a stub, because it doesn't yet have the actual fully developed code. It just is like a placeholder for when that code gets developed, tested, and ready to go. It can then be placed right inside these curly braces. So the first one is print month title, and that should be rather straightforward. No, there's nothing to run. This is a stub. So it does nothing. The next stub inside here is the print month body. That too doesn't have anything in here at all. The stub for get month name, it's going to return back a dummy value. We'll call it January. The get start day, well, we're going to go ahead and return just a 1. The 1 could mean Monday, the first day of the week. Next is going to be the get the total number of days. In our requirements gathering, we determined that this calendar program needs to be able to print months that go all the way back to 1800. So for this, that's a rather complicated problem, but for this stub, we're just going to put 10,000 as a placeholder. So we'll return 10,000 to be the total number of days. And then get number of days in a month, well, we'll just put a placeholder, a dummy value of 31 to be returned. And is leap year, we'll return a Boolean, and we'll just go ahead and put a dummy value of true in there. All of these are stubs, later to be filled with the developer's code. I can run this, and I can put in 2010 and March, and it doesn't do anything because there's no code in this. But yet it compiles and it runs, and now we just need the actual code for each of those methods. That is known as a top-down solution approach. There is another approach, the bottom-up approach, although I don't see much of an example of where that happens. All my experience has been with top-down solutioning. And the benefits of stepwise refinement is to make the program simpler, to reuse all of those methods. Clearly, you would want to be able to reuse is leap year. I would think that that would be used in an awful lot of programs. Easier developing, debugging, and testing when you use stepwise refinement, and better facilitating of teamwork, because in all likelihood, all of those stubs are being developed by different programmers, and they are all going to need to be able to talk and make sure that they are developing concurrently and using maybe the same variable names, and it promotes for good teamwork using stepwise refinement. And then finally, we'll show the print calendar in operation. I will run this, and I'll put in today's date, and the month is March, and it quickly printed out this month's calendar. March 2016 is nicely formatted. The start day was Tuesday. Today is March 30th, Wednesday. So it works. It's calculating correctly. Quickly going over the structure of this, you'll see that we used the skeletal approach with stubs, but now all the stubs are filled in. So we get the year, we get the month, and we call the print month, passing it year and month. Print month right here gets year and month and calls the print month title. Print month title getting year and month is right here. And here is we have a nice, neatly formatted print month title, which is down here. March 16th, March 2016. The only real confusing thing is it needs to get the month name. So in here, the get month name, we're passing it the 3, and it goes to another method, and it will determine how it gets the month name. I would think that would be a switch statement. It's right here. So get month name is a switch on 3, and it would come down to month name and pass back the March, and then make sure you issue the break statement. And so now March gets replaced in here along with the divider, and then the months, the days of the week. And then as you can see, as we go through each one of these methods, they can be rather complex, but then again, many different people worked on this. And you can see how to print the month body, get start day. Here is the start day, for instance, for January 1st, 1800 is 3. So that might be Wednesday. They may have looked it up and said, okay, well now, how many days is today since January 1st, 1800? Well, get total number of days, passing it year and month, and then come down here. You got to determine if it's leap year or not. And if it's leap year, you're going to accumulate the total number of days by adding 366. Otherwise, you're going to be adding 365 to the total. And here are the other remaining stubs that have gotten filled in with all the different methods. And is leap year is a straight return. Is leap year is not as simple as just dividing the year by 4. There are considerations when you're working with the centuries when it's divisible by 400, and also if it's divisible by 100. And so we have if the year, for instance, year is 2016, is modulus 400 is equivalent to 0, or 2016 modulus 4 is equivalent to 0, and year 2016 modulus 100 is not equal to 0. That's the formula for determining leap year, and that will return either a true or false. In the case of 2016, it's going to return back a true. This year is a leap year. All right, so that is the print calendar. Complex assignments, complex program, broken apart using stepwise refinement, and then assigning each of these methods to different programmers depending upon their skills as to what they can handle and what they can't, and hopefully it all comes together and tests thoroughly in a very short amount of time. All right, I think that brings us to the end of the PowerPoint and the end of methods. Yep, that's it. Let's go to the participants, and we have Julio and Michael. You guys have been very patient. Are there any questions at this point on everything that's been covered in the methods chapter?
Pause the recording before you ask.
I'm sorry, one more time?
You got to pause the recording before you ask.
I'm not sure what you mean.
I said it. Pause the recording. Since you already recorded the whole PowerPoint and examples, you got to stop the recording before you tell us to ask some questions.
Okay, I can do that, okay, but I want to have other people that might want to listen to the recording benefit from your question and also an answer. So
I have a quick question, Professor.
Okay.
The void methods you said to be used as a single statement, separate statement.
Yes.
Can we do the same with a method that returns something if for any reason the actual return of the method needs to be ignored? So will the compiler give us an error if we do something like that?
Yeah, well, it's not going to know where if you're returning an int, it needs to now get placed into something. So if your return is an int and you get a 7 calculated, that 7 is going to need to be placed in a statement of some sort or get assigned into another variable.
But if we use it as a standalone, so basically ignoring the return, will it compile?
I don't believe it will. Okay, because it's got something. Go ahead.
That would be a logic error. You know, if by mistake one places a method that returns something, maybe mistakenly thinking that it's a void method, and so the compiler will recognize it, you're saying?
Yes, I believe it will. I'd have to test it, but my inclination is to say yes, the compiler's not going to like that. I know you can issue a return statement from a void method, but not returning a value.
Okay. So
all
just
right,
a return statement has to go back to the main program.
That's right. So you're returning control, but you're not passing any value, whether it's an int, a double, or a string, or a Boolean, or whatever. It's just returning control back from whence it came, and it will go to the next sequential instruction.
Okay. All right.
All right. Okay, but no values.
Okay. Yep.
Okay. All right. Thank you, Julio. Good question. Any other questions?
Not from me.
No. Okay. I mean, Michael, do you have a question that you would like to ask that's not recorded? If so, I can stop the recording now. And
about what you said earlier, the loops lab assignment. Well, even though you said it's optional, right?
Yeah.
Oh, I decided not to do it then.
Okay. I mean, as I say, that's optional. It's your choice.
Yeah.
Any other questions?
No, not from me.
Okay, Michael, you're all set?
Yep.
Excellent. Great. All right, gentlemen, thank you very much for your patience. It was a long one tonight. Hopefully it was beneficial, and we'll call it a night. And the next webinar will be at the end of the arrays chapter on Chapter 7. Thanks again for participating, and guys, have a good night.
Thank you, Professor. You too.
Thank you.
Thank you.
Bye-bye.